Hello everyone, this is teacher Zhao Haikuo from Fountain Education. Today we are going to learn something about secrets in regular hexagons. Okay, this is a question from Chinese Math Olympiad. Now let's see. I've shown in the figure some of the vertices of the regular hexagon are connected to a point inside, which forms 6 triangles, and 3, x, 7, and 8 are the areas of the 4 triangles. It asks us to get the value of x. Okay, which means the area of the triangle. Okay, now some of you must be confused at the first sight of the question because it is such difficult. But don't worry, okay? Don't worry. Now let's see. If you want to get the area of the x, you must get its base and its height. But we don't have in this question, so the conditions are limited in this question. And the second difficulty is what? Yes, it's more than one unknown number. Okay, some of you must ask that. There's only one unknown number. Why did you say there are more than one unknown number? Okay, now I will ask you a question. Do you know the area of these 2 triangles? No, you don't. So there are more than one unknown numbers. But don't worry, okay? Since this is difficult, let's try something easier, okay? Look at the example. Here are 2 parallel lines. Suppose there is a point between them. Connect the point to the 2 lines to form 2 triangles whose lengths of bases are the same. These 2 are the same. And one's area is 6 and the other is 4. Now, and here's another point. The point is moving to here. And another 2 triangles whose lengths of bases are the same to the former 2, which means the 4 bases are the same. Okay, one's area is 3 and what's the area of the other? Okay, it asks us to get the x. Do you know how to do it? No, we don't, but don't worry. Let's bring the figure out. Suppose this is S1, which means the area of the triangle, and this is S2, S3, and S4. So, according to the formula of getting the area of the triangle, do you know the formula of S1, S2, and S3, and S4? Yes, you do. Okay, this is the formula. S1, S2, S3, and S4. Now, guys, we have known that the point is changing to here. But do we know what are not changing? Yes, we know. What's it? Yes. The bases are not changing, and don't forget that these 2 lines are parallel. So the distance between the 2 parallels is certain, right? Okay, now can you tell me what is, suppose this is h, what is h equal to? Yes, it's equal to, suppose this is h1, this is h2, then it's equal to h1 plus h2 and h3 plus h4. So we can list the formula as this and this. Now tell me, what's the relationship between these 2? Yes, very good. Since these are the same, so this is the same. Now let's make a conclusion. This is the same figure. If there are 2 triangles whose bases are on 2 parallel lines with the same length of the base and connected verticals, the same length of bases, okay? So the sum of their areas is certain. Okay, now let's see. What does it look like? Yes, it looks like a teeth. And this, yes, it's also a teeth. So now we have called it teeth model. So when should we use this model when solving questions? Now, you must remember that next time if you find 2 parallel lines and 2 triangles between them, try it. Okay, now let's go back to the original question. Are there any teeth models? Yes, certainly, because these are parallels. And these are parallels, and these are parallels. Where are the triangles? Yes, these 2, and these 2. So we can know that since 3 plus 8 is 11. So now tell me, what's this? Yes, it's 4. And what's this? Yes, it's 11 minus x. So did we solve the question? No, we didn't. So what should we do? We don't know, but don't worry. Let's try something new again. Okay, something new and something easier. Here are 2 equilateral triangles which are the same. finding one point in the triangles. Okay, one point. This is the point and this is the point. It is changing again. Its corresponding height to the side. Its corresponding height to the side. And the lengths of the heights are given. They're all 3, and this is 3, this is 1, and this is what we are going to get. So what should we do? We don't know, but did we know the method we used in the last question? Yes, we did. Something is changing, but something is not changing. So what is not changing? Despite the numbers, let's use this figure. Suppose this is H1, this is H2, this is H3. Now, follow me. Connect these 2 points. These 2 points and these 2 points. Now, there are 3 triangles. Have you seen it? No. So, now, let's mark it red. Let's mark it purple. And let's mark it yellow. Okay, now, suppose this is triangle 1. Okay, this is S1, this is S3, and this is S2. Now, tell me, what's the area of these 3 triangles? Yes, you must know. Okay, and there's a big triangle. What's its area? Yes, we can know that. It's half of A times H. H is the huge height. Okay, now, and these 3 triangles are this. Now, guys, tell me, what's the relationship between this and these 3? Yes, you have found that. The result is 8. And then, so now tell me, what can be removed? It can be removed and it can be removed. So the result is H is equal to H1 plus H2 and H3. Now, it's over. It's over. Okay, now let's make a conclusion. Equilateral triangle. So, in the equilateral triangle, using a point inside it to draw 3 heights to its 3 sides. 3 heights, 3 heights. Okay, the sum of the height is certain. The sum of the height, so this 3, their sum is equal to the sum. Okay, now look at it. What does it look like? It looks like a letter Y. So we call it Y model in equilateral triangle. Okay, now let's go back to the original question. Are there any Y models? No. There's certainly no. Did you remember, where does the Y models lie in? They lie in equilateral triangle. So, can we do something to make it an equilateral triangle? Yes, certainly we can. Now, I will play a trick for you. This is a trick. This is an equilateral triangle. This is a point, and this is the height. This is the height, and this is the height. Is there only one way to make it an equilateral triangle? Certainly not. There is another way. Look at another magic. Yes, we got another equilateral triangle. And this is the height. This is the height, and this is the height. So, suppose this is triangle, this is triangle 1, 2, 3, 4, 5, and 6. This is the same. 1, 2, 3, 4, 5, and 6. 6. It's 6. Now, guys, tell me, since these 3 heights, the sum is certain. It's equal to these 3 heights. And this is a regular hexagon. So the basis must be the same. The basis. Okay, now let's change it to the other figure. Now tell me, what's the area of S1, S3, and S5? Yes, it's equal to this. And S2, S4, and S6? Yes, it's this. Guys, tell me, they are equal. And what's the relationship between this one? Yes, we have got that. They are just the same. So, what's the relationship between them? They are equal. What's the relationship between these 2? Yes, they are certainly equal. So, we have known that. These 3 is equal to these three. Okay? Okay, now follow me. Is it right? We don't know, so we use some special cases to prove it. Okay, this is a special case. Right? No, this is the conclusion. Okay, before we make a special case, we use this conclusion. Conclusion of regular hexagon. If there's a point in a regular hexagon connected to the six vertices, the sum of the areas of three triangles, remember, with common verticals. What is common vertical? Yes, it's this. And no common edges. What is no common edges? Yes, which means 1, 3, 5, and 2, 6, 7, 6. Okay, it's certain. Their sum is certain. So, is it right? Now we can prove it. Okay, use a special case. Suppose this point is in the middle of the regular hexagon. So, what's the relationship between these two formulas? Yes, that's totally the same. Because the six triangles are all the same. Okay, now we have done it. Right? Okay, let's go back to the original question. Tell me, is it hard? No, it is so easy. Why? Because we have known that this is 11 minus x and this is 4. And this 3 is equal to this 3. So, now we can list the formula, which is 3 minus 7 minus 11. Okay, 3 plus 7 and plus 11 minus x is equal to x plus 4 plus 8. 21 minus x is equal to 12 minus x. 2x is 9, so x is 4.5. So this is the answer. We have done it. So some of you must be confused again. Why did you use the two models to tell us the result? Now let's see. Have you seen it? This is the original question. This is the regular hexagon. This is the Y model, and this is the, using this. And this is the TIS model. So there are two models in the regular hexagon. Okay, today's video is and the class is over. Okay, thank you for your watch. And if you like us and want to get more explanations of Chinese Math Olympiad, please subscribe us and like us.